Hey guys, in this video lecture we will be solving your mathematics class 10 exercise 1.3. So our first question is you have to prove that root 5 is irrational. So moving towards the proof part, we will first assume in step number 1 that root 5 is rational. We will prove all these by contradiction method. So assuming that root 5 is rational. So, this root 5 can be represented in the form of a by b, where b is not equals to 0 and a and b are co-prime. Why they are co-prime? Because this a and b are always in the simplest form. When we write it as a by b, it's in the simplest form, and simplest form means these two a and b don't have any other common factor. So that's why co-prime, since they don't have any common factor. Okay, so since this root 5 is equals to a by b, so we can write it as, in step number 2, you can write it as a is equals to root 5b. So from here you can also write squaring on both sides, that is a square is equals to 5b square. This can be written. So a square is divisible by 5, you can write it like that, or that is why we can write that 5 is a factor of a square. We can write as 5 is a factor of a square. Therefore, 5 is also a factor of a. Okay, by fundamental theorem. We can write it like this. So now, in the third step, you can write it as a is equals to 5 into, since see, 5 is a factor of a. So for writing the factors of a, you will definitely get 5, and along with 5 we will get one more thing, one more number or few more numbers, and those numbers we are considering as c. So a is equals to 5c. Okay. Now this a is equals to 5c, substituting this value of a in this equation. Substituting this value of a in this equation, we will get, in step number 4, you will get 5c whole square will be equals to 5b square. That will give you 25c square is equals to 5b square. And from there, you can also write it as that b square is equals to 5c square. Taking this 5 down over here, you will get b square is equals to 5c square. So now in step number 5, you can that's why write it as that 5 is a factor of b square. 5 is a factor of b square, and therefore 5 is also a factor of b, right? By fundamental theorem, 5 is a factor of b square, and therefore 5 is also a factor of b. So in step number 6, now looking at step number 2 and step number 5, looking at step number 2 and step number 5, we notice that 5 is a factor of a and 5 is also a factor of b. So from 2 and 5, we can write that 5 is a factor of both A and B. But as we assumed that root 5 is equals to A by B, that is root 5 is rational, we have assumed, and that is why A and B were co-prime numbers. So as they were co-prime, this A and B did not have any common factor. But here we got that root 5 is a common factor of A and B. So our assumption was wrong. Therefore, our assumption was wrong, and therefore root 5 is irrational. Okay. This is how you will prove this out. Moving to the next question. Here in this question, you again have to prove that 3 plus 2 root 5 is irrational. So we will assume that 3 plus 2 root 5 is rational. Assuming it to be rational, this is step number 1. Now assuming it to be rational, you will get 3 plus 2 root 5 is equals to A by B, where A and B are co-prime integers and B is not equals to 0. Okay. So, step number 2, again writing the same part, that is 3 plus 2 root 5 is equals to A by B. You can again write it as 2 root 5 is equals to A by B minus 3, or root 5 is equals to 1 by 2 inside the bracket A by B minus 3. Now, since this A and B are integers that we have already assumed, A and B are integers, so this part has to be rational. Now, if this is rational, this root 5 should also be rational, but we know that root 5 is irrational. So, our assumption was wrong that 3 plus 2 root 5 is rational, and therefore this is an irrational number. Now, moving to the next question, it's that prove that the following are irrationals. And the first one is, we have to prove that 1 by root 2 is irrational. Okay. So, for proving it irrational, by contradiction method we will move. Assuming, in step 1, assuming that 1 by root 2 is rational. Then, if it's a rational number, then 1 by root 2 can easily be represented as A by B, where B is not equals to 0 and A and B are co-prime integers. Okay. So, now moving to step number 2, 1 by root 2 is equals to A by B, that we have already assumed. So, by interchanging the numbers, A root 2 is equals to B, that is, you can write root 2 is equals to B by A. So, since this A and B are co-prime integers that we have already assumed, so this B by A should be rational. as these are integers, so integers will always give you rational number. And now since we have already learned that integers are always rational, so it will give you rational number only. So this should also be rational because these two are equal, but we know that root 2 is irrational. So our assumption was wrong and 1 by root 2 is irrational. Okay, moving to the next question. Assuming in step number 1, we will assume that 7 by root 5 is rational. And if this 7 by root 5 is rational, so it should be equal to a by b, where b is not equals to 0 and a and b should be co-primes. Right? This is what we will assume. These are co-prime integers. Okay, this is our assumption. So here, writing the same equation once again, 1 by root 5 will give you a by b. So from here you will write a root 5 will be equals to 7b, and that is why root 5 will be equals to 7b by a. Now since this a and b were co-prime integers, means they were integers, so this will give you rational number. But this root 5 is irrational, but this irrational number cannot be equal to this rational, so this is a contradiction. Therefore 7 by root 5 is also irrational and our assumption was wrong. Moving to the next question. So our next question is 6 plus root 2. We have to prove it to be irrational. So in the first step, we will assume it to be rational. Then 6 plus root 2 will be equals to a by b, where b is not equals to 0 and a and b are co-prime integers. Right? So in step number 2 you will get, I'll write this equation once again. 6 plus root 2 will be equals to a by b. So root 2 will be equals to a by b minus 6. That will give you b a minus 6 b. But this should be rational. This is a rational number. Why? Because this a and b here are integers. Our integers always give you rational number, so it should be rational. But we know that this root 2 is irrational. So this is a contradiction to our assumption, and therefore we will write it as our assumption was wrong and 6 plus root 2 is irrational. Okay, thank you.